Hello everyone, welcome back to our ArcGIS channel. In the previous lab, we learned how to build a network dataset for ArcGIS network analysis in ArcGIS Pro. We also learned how to conduct route analysis, which was to find the shortest path or quickest path between multiple points, and also conducted closest facility to identify the closest facility to an incident. For example, finding the closest police stations to an incident. In this lab, we will continue other functions in ArcGIS network analysis that are service area and location allocation analysis. So let's get started. So first of all, open up ArcGIS Pro, create a new project. So I'm going to call this network 2. And I am going to save it in my GIS lab folder. I'm going to create a new folder. I'm going to call it 11 network analysis part 2, and then OK and OK. First of all, let's add the data of the network that we built last time. I think if we go to the GIS lab, lab 10, here we created a geodatabase, right? And then within that we had a feature data set. And here you can find the network dataset and also the junctions. And I also would like to add hospitals and also fire stations and the county and block group in the Union County. Okay, so click OK. So if you remember, we mentioned that we got the fire stations and hospital information from the HIFLD, Homeland Infrastructure Foundation level data. So we got the block group information from Esri website and road network from the Union County website. I am going to uncheck unnecessary data. So I am going to uncheck the junctions, county. Maybe I should change this color to, for example, this one, and maybe no color. But for outline color, I'm gonna use the blue and increase the outline width. So that's for the county. But for the union, block group union, I'm gonna use no color. So here you can see the results for the NDS, right? The roads. But still, I don't need to show the roads. I just wanna keep the hospitals. So how many hospitals do we have in this county? So we only have one hospital. And also I am going to keep the fire stations. Okay, so hospitals and fire stations. So how many fire stations do we have? We have 9 fire stations in Union County. So for the first analysis, I'm going to even uncheck the fire station. So here is the location of the hospitals in this county. So what is a service area? So using service area, we can find catchment area or service area around any location. Okay, for example, we have this location here. If I drive 5 minutes from this location to any direction, okay, so from this location, if I drive for 5 minutes, all possible locations that I can reach in 5 minutes, so that is a 5-minute service area for this location, okay. So if I drive from this location for 10 minutes, all possible locations that I can see, so this is the 10-minute service area, okay, and also similarly 15-minute service area. So the results can be shown as a polygon here, as you can see. The results can also be shown as a road segment that includes all roads in a given time. So the cost or impedance, so here is based on minutes, right? Based on the travel time. But you could also have the cost or impedance based on the distance, right? For example, so here was 5-minute drive. We can say 5 miles. If I drive from here, all possible locations that I can reach in 5 miles. So service area looks like buffer, but more sophisticated version of the buffer, right? Because in buffer, we use Euclidean distance or straight line, but service area is based on existing road networks or travel time, okay, along the road network. So our research question is, how hospitals in Union County in Ohio serve people? And do all people have access to the nearest hospital in this county within 20 minutes drive or not? And if not, where are the people who need to travel over 20 minutes to get to this hospital in this county? So to answer that, we need to use service area analysis in ArcGIS Pro. So let's look at the roads. I think I have to also add the data for the roads from feature data set. So here are the roads, right? So if you open up the attribute table of the roads, I just want to show you that the last time we created two cost fields, right? Miles, which was the length of each of the segments of the road, and also the travel time for each segment, it was in the minutes. Now close the road, so I just wanted to show you. I can uncheck the road. So in order to work with the ArcGIS network analysis, so I have to first click the network data sets, select it, and when you select it, you can see that data and network dataset layer will be added. If you go to data and network analysis, here you can find, for example, service area, which creates service area or drive time polygon, right? So when you click that, a new layer will be added to the table of content. So here we just need to introduce what is the facilities, which obviously our facilities are hospitals, and also define the costs. And the process is very similar to what we did in the previous lab, right? So if I go to the service area layer, so here I have to import the facilities, right? So or I can create a facilities, but here for hospitals, it's better to import the facilities, right? So click on import facilities, and my input location is going to be the hospitals, right? So what happens here is that I am going to connect this location or load the location to the network. Okay, so it has to be connected to the network. So that's how this process works. So we have to, for example, here, as we mentioned, so we can set different tolerance. If the distance from this location to the road is higher, like maybe it's in the over 5,000 meters, so do not connect it, right? So maybe I can change this to 1,000, and everything looks good. So when you click apply and OK, so what happens, as you can see, if you open up the attribute table for facilities, you can see that this one hospital has been loaded successfully. The color has changed, right? Similar to the previous lab that we mentioned, you can also define the point barrier, line barrier, polygon barrier. Maybe there was some construction and you would like to avoid that or circumvent the constructions. But here we keep it very simple. So, but you can, again, you can load the barriers or you can create the barriers, doesn't matter. So the next one, you have to go to the travel settings. So I would like to find, for example, first of all, 5-minute drive. Okay, so I have to remove this 5-minute drive. And so here are hospitals, and you normally drive to hospitals, right? So you have to select the tort facility, right? The reason is that maybe the tort facility and away from facility, the direction can impact the traffic. But for our analysis, they are both the same, but here, just to make sure that tort facility means that you go to the hospitals, right? So the cutoff value, if you go to the travel settings, here you can define the cost. So the cost is based on minutes, so it's 5 minutes drive. So I would like to see where can I go from 5 minutes from these hospitals, which areas can come to the hospital in 5 minutes, okay? So here is if you have the traffic information for different days or different time of the day. So I can say that if I want to provide the polygon, the result as a polygon or the result as a line, so I'm gonna select polygon. And here, so this is more applicable when you have multiple points and when they overlap. So what happens? Whether they should be dissolved, like this merged, or they should be splitted, or whether if they overlap, they have to be independent for the service area, right? So this is not a problem here because I only have one hospital, and this is not an option here. But when you have an hospital, maybe dissolve it, maybe split it. So it's up to you. So And also, so you could import the facilities, you could import the point barrier, line barrier, polygon barrier, so everything looks good. I just need to click on run. So what happens is that in 5 minutes, I can reach these locations, okay? So if I drive 5 minutes from this hospital, I can reach all of these locations. So you could also add, like, for example, 5, 10, have multiple, 15, 20. So you could have multiple cutoff values, right? So I would like to know, for example, between 0 to 5 minutes, between 5 to 10 minutes, 10 to 15, 15 to 20, where are the service areas, right? So settings are the same as the previous one. Click run, and here are the results. Okay, so the results, I probably need to change the symbology, to change the color. So if I go back to the, so the results are here, the polygons, right? So let me first change the symbol. Probably different color would be better, maybe this. So in 5 minutes, so you can also create a map at this legend. In 5 minutes, I can drive this location. Between 5 to 10 minutes, I can drive this location, 10 to 15, 15 to 20. So these are the areas. If I, for example, turn off the NDS, so these are the areas that can be reached in maximum 20 minutes, right? So these are the areas, people in these areas do not have access to this hospital within 20 minutes drive, okay? So they need to travel in these areas or in these areas. They need to travel over 20 minutes to get to the hospital in this county. You could also change this cutoff value to cost based on miles and then run it again, and then you could get another result, right? So another thing, again, you can do, for example, you can set the, instead of polygon, I would like to generate just lines, okay? And then click run. So here are the roads that I can reach in 20 minutes, right? And how about polygons and line? Run. So it shows the polygon and also lines that you can reach in 20 minutes in different cutoff values. So now let's move to the location allocation analysis. Okay, so to better understand it, let's set up a scenario that you are a GIS expert and the officials of the county have been faced budget deficit. And they must reduce the number of fire stations from 9 to 5. So let's say they have multiple fire stations. They would like to select the some of them, like for example 5 out of 9. And we would like to identify the fire station that should remain operational to ensure best response time to the residents of this county, okay? To answer this type of questions, this type of optimization problems, we have to use location allocation analysis. And so location allocation analysis is used when decision makers need to determine the most optimal locations or facilities or resources to serve the demand point. So the demand point is going to be the population of each block group, right? And it is particularly useful for accessibility, coverage, cost, response time. So when these are critical, so we use location allocation analysis. Turn off the service area and analysis. I only wanna keep the fire stations and also block group union, so that's it. So where is the fire stations? Here. So how many fires? I think 9 fire stations, yes. And also for block groups, so how many block groups do we have in Union County? 30 block group. And also for the 30 block group, we have a field that is population, the population of each block group. So we would like to identify out of these 9 fire stations that we have. Okay, so let me change this color maybe to red. Gallery. So these are the fire stations that I have. I would like to select out 5 out of 9 fire stations that provide the best response time to the demand point. So what are the demand point? So demand point are the population of each block group, okay? So the first question is, which location in the block group is considered the demand point? And to answer that, we normally select the center of each block group. Okay, so you have to find the center of each block group. Okay, so you have to go to Analysis tab, Tools, and then type Feature to Point. It will extract the centroid or center of each of these features of each polygon. Okay, so click on Feature to, so input feature is going to be my block group union, right? BG union. The output feature, I am going to call it like just demands. Okay, so I'm gonna save it in lab 11. I'm gonna call it demands, right? Because these are our demand point. So inside, if you leave it unchecked, the output will be the center of gravity of each block group, which can even be outside of each of these like block group, which is okay. We don't have problem with that. So if you check it, the output will be located within the input feature, but we don't want to force that. And then click Run. So as you can see, for each of these block group, find the center of gravity. So if you open up the attribute table for these demands, population is very important here. Okay, population serve as weight for demand. So the higher population, the higher demand, right? So if you, for example, change the symbol, maybe use a proportional symbol for population. So here we can see, here we have higher demands. Okay, so as I mentioned, so the type of analysis that we need to do is select some fire stations out of, for example, 5 out of 9. So we have to use location-allocation analysis. Select the NDS, and then click Data, Network Analysis, and then select Location-Allocation. Choose the best location among the location that you have. Okay, so as you can see, when you select the Location-Allocation, a new layer will be added to the table of content. So here we need to define what are the facilities and also what are the demands. So we have the demands, which are the centroid of each of these block group, and the facilities are our fire stations, right? So again, we need to load them onto the road network, right? So if you go to the Location-Allocation layer tab, so our facilities definitely are going to be the fire stations. I'm going to import that. So the input location is going to be the fire stations. And here for the fire stations, I can, again, you can, for the search tolerance, for example, I put 1000 meter because of my study area is small. Apply and OK. So let's see what happens. So as you can see, all of these fire stations have been loaded as candidates. Okay, so if you open up the attribute table for the facilities, now I have 9 candidates. As you can see, facility type is candidate. And so let's close this. So the next thing that I have to do is that I need to import the demand points, right? So if you click on import demand point, so input location is going to be the demands, right? But how can I say the higher population, higher weight? So when you click on, you have to click on weight, and then here you have to introduce which field represents weight. For me, population. The higher population, the higher weight. And also, if there was no population in some field, just use the value of 1. We don't have problem with that. And everything looks, so I can also change this to 1000. I think there was 30 block group, right? So when you apply and OK, so all of the 30, as you can see, demands point have been added. So if you look at the attribute table, all of the 30 have been loaded as demand. And also here we have the weight, which is the population that we introduced. So let me change the color just to differentiate it with the facilities, maybe blue. And also you could import barriers, point barrier, line barrier, polygon if there were some construction, if there was some military area, protected area. So you want to avoid those areas in your analysis. You could also import the barriers, okay? So the question here is that, are you going to the fire station or they come to you? Okay, so they come to you, right? So we have to select away from hospitals, again, because the direction, maybe the direction impacts the results. But here we assume that in both directions the speed limit is the same and the traffic is the same. So this is not a problem here, right? So I would like to know the total minutes and also the accumulated miles. And here I can select how many facilities I would like to select, right? I would like to select 5 out of 9, right? So I have to increase this to 5. And then cost. So I would like to minimize the travel time, right? The overall travel time, not the travel distance. So the cost is going to be minutes. So it is okay. So the problem type here is important. So we have a variety of optimization problem that we can solve in location allocation analysis. For example, here, minimum weighted impedance. Impedance here was actually the time, right? The minutes, right? So we would like to minimize the overall time. Which 5 facilities or fire stations have to be selected in order to minimize the overall travel time. So I would like to select this. Again, you can also introduce the time and day if you have the traffic information. We don't have that. Output geometry. Do you want to, so this is only for visualization. Do you want to show the result or do you want to show the result as a straight line? So the result will be shown as a straight line, but it is based on the road network. And click run. So what happened is that first of all, it found 5 facilities, right? These are stars that has the stars, like 1, 2, 3, 4, and 5. They are chosen, but some of them they are still candidates, right? So if you look at that, so this one, this one, this one, this one. So these 4 are candidates. If you open up the attribute table for the facilities, so as you can see, the facility type now, before that all of them were candidate, but now some of them are chosen. So these are 4 of them are candidate and 5 of them are chosen, right? And another thing is, for example, how many demand count, right? How many block groups they can serve, right? For example, this one, this is an important facility, can serve 10 different block group, right? And so this one can serve 5 different block group, 1, 2, 3, 4, 5. So this one shows a straight line to represent it, but it is based on the road network, right? And so these facilities do not serve any, these fire stations do not serve any of these block groups. So we can remove them, right? And also they have mentioned, I think, the distance or total minutes. Okay, so for example, for this one, the total minute is 23 minutes, 44 minutes, 24 minutes. But for the others that haven't been chosen, they haven't mentioned anything, right? And also for the total weighted minutes and also for the miles. I don't think they have considered miles because for analysis that we had, we minimize it based on the minutes. So if you close this and then unselect all of the selected, so let's look at the lines, right? So if I open up the attribute table of the lines, so for each of the, so we had 30 block group, right, for the demands, right? So first of all, for example, for this block group number 1, so this one, so you can see, so which facilities are closer in terms of time to this block group, facility number 4. So we had like 1 to, we have selected 5, right? So we have facility number 4, 6, 7, 8, and 9. So each of these have a name, which are facility number. Demand ID, so these are also each of these demands have an ID from 1 to 30. Weight is the population. So these are these are not important. The most important thing is the total minutes. So from this fire stations to this location, they have to drive 8.59 minutes to get to this location, right? And also the total mile, okay? So if you sort the values, the minimum driving time is less than 1 minute and the maximum driving time is over 10 minutes, right? So for example, for this one, as you can see from this fire stations to the center of this, so the center of this block group, they have to drive over 10 minutes to get to this location. So another question is, we would like to maximize the coverage, but we would like to be within 9 minutes drive, okay? So we want to select 5 facilities that provide the maximum coverage, but everything has to be within 9-minute drive. Okay, so in this type of scenario, we have to use maximum coverage and set some cutoff value. So how we can do that? Again, very simple. So let me clear selected features, close this one. So if you go back to the location allocation analysis, so I would like to provide the maximum coverage. So here is not to minimize the overall time. I would like to provide the maximum coverage. But again, I would like to select 5 out of 9. But the travel time, I can here put the cutoff value. I'm going to have like 9 and then run. So as you can see, it cannot in 9 minutes. First of all, it selected the 5 facilities, right? 1, 2, 3, 4, 5. But in 9 minutes drive, so some of them cannot like be served, right? So if you open up the attribute table, for example, for line, so it shouldn't be 30 demands. I think it should be 29 or even less. I'm not sure about the other points, but now we can see that there's only 29 locations or 29 demand that can be served. But if you look at the total minutes, it's all of them, they are less than 9, right? So if you, for example, put 8, less than 8 minutes, probably this one also will be excluded, right? So let me try this, 8 minutes, and then run. It has to be 28, as you can see, right? So you can put also cutoff value, but to provide the maximum coverage. So another type of question that you can solve is that you can let ArcGIS automatically finds the number of the facilities, the minimum number of the facilities based on a given cutoff value. Okay, let's look at the question. So we would like to find the minimum number of fire stations so that all response time is less than 12-minute drive. So in order to respond to this type of question, we have to use the problem type, we have to use the maximize coverage and minimize facilities. Okay, so according to description, it solves the fire station location problem. It chooses the minimum number of facilities needed to cover all of the greatest amount of demand within a specified cutoff value, okay, or impedance cutoff value. So for example, I would like to set the cutoff value to 12 minutes. So let me make sure the travel setting is also cost is minute, yes. But this time, if I select this, so look at the facilities. So it will be disabled, which means that I cannot select the number of facilities. ArcGIS will select the number of facilities, but based on this cutoff value, which is 12. So if you run the analysis, and now if you go back, if you open up the attribute table of the facilities, so let's see how many facilities have been selected. So there were some candidates that were chosen, right? So as you can see, there were only 4 facilities. If we would like to, the minimum number of the facilities, if we would like to set the drive time to 12 minutes. So we don't even need to have 5 facilities. If the driving time, if the cutoff value is less than 12 minutes, 4 is enough. So other type of problems, optimization problem that you can solve with location allocation analysis, for example, for market share, for maximize attendance. So feel free to explore other options in the location allocation analysis.